5. This week we'll be talking about user input, which we discussed a bit last week, and debugging. So in the previous lecture, we discussed a few different concepts. We talked about scrolling views, which are the views where you can scroll. The caveat to that being that all of its children render before the whole view renders. We talked about a couple virtualized lists, flat list and section list. Those are the couple lists where they're much more performant because they'll only render what's in view. The difference being that section list allows you to separate your data into separate sections and have a section header to go along with those. We then started to talk about user input. We talked about the difference between controlled and uncontrolled components. Controlled components being those components that track state, and the source of truth for the input's values are on the component state itself. Whereas uncontrolled components are those where the DOM, or in the case of the browser itself keeps track of those inputs values. We then talked about text input for a little bit, which it was the component used to accept user input. And first we'll talk about user input today. And so we talked briefly about controlled versus uncontrolled components, and how for React Native you need to use controlled components. React recommends always using controlled components even when using React Web as well. And so we looked at how user inputs take a couple of different props. One, value, which dictates what the value or what displays inside the text box is, and then onChange text, which is the callback that is invoked every time you change that value. And so the docs are linked in the lecture slides, and so let's take a look at the example that we were looking at last week. So last week, we were writing this application where we have a section list here, and then we were starting to add a screen where we can add contacts to that list. And so where we left off last week, we could type into the name here. We could type into the phone here, but nothing actually happens with those values. And when we click submit, nothing happens. So let's build out the rest of that app this week. So in add contact form, when we left off last week, we had a few things written. So we kept track of the name and the phone number in state. Let's actually get rid of that line here. So we kept track of name and phone in state. Since we're using controlled components, the component itself has to track the value of those texts. We wrote two separate handlers, one called handle name change, which takes a name, which is fired when you change the text input down here. And then it just sets the state so that the name, the key name, is equal to whatever values passed in. And so that, when passed a string, will just update the state value for name. We have the same function down here, but for phone. And so when you pass in a new phone number down here, it will just set the state such that the new phone is equal to whatever string you pass in. And then in the render function, we just define those two text inputs. So one has a value of this.state.name. And so every time we change this.state.name, the value is then reflected in this text input. We set its onChange text prop to equal that handle name change function that we defined above. And then just as a placeholder, we wrote name so that when the field is blank, the user just knows what they're supposed to type in there. And then we have the same text input down here for phone, with the one difference being the keyboard type. And so we don't really want users to be able to type letters into the text input. And so we said, what kind of keyboard should pop up? Oh, only that numeric one. And so as we see in our app, when we click on the text input here, we only see the numbers. And so now we have a page that is actually handling multiple inputs. And so the way we handle that in web is we have a form component. And so that form component in HTML takes the onSubmit handler, and when you submit the form, that gets invoked. Unfortunately, that does not exist in React Native. But since we're using controlled components, we actually maintain an object with all of the form data. So again, this form component does not exist. But the analogy is that for whatever component that we're writing, all of the information that we need is tracked in the state. And so we're actually maintaining an object with all of that, all of those inputs values. And so what we can actually do is we can define a function that handles the data to submit. And so that would be the analogy to the onSubmit handler in web. And so let's go ahead and do that in our example. And so here when we click submit, nothing actually happens. But what do we want to happen here? Well, when we click submit, ideally that this form gets submitted and we add a contact. And so here, we already have a button called submit, but we haven't said what it should do when we press it. And so let's define an onPress. And so onPress is going to invoke this function called handleSubmit, which we have not yet defined. And let's go ahead and define it up here. So as you recall, when you press a button, the onPress handler gets invoked with no arguments. And so we're going to actually have to decide what to do here with no arguments. And so we should go ahead and do this .props, because since this is just a generic add contact form, we're not defining the logic on adding the contact here. We're just going to define the form here. And so we're going to assume that a prop called add, or let's just call it onSubmit, exists, and we're going to pass it an object with the state fields that are necessary. And so we could do something like name is this state.name, and phone is this state.phone. Or the shorthand for here, since we're using every single key value pair of this .state, we can actually just do this this .state, which means take all of the key value pairs of this .state and create a new object with those key value pairs. Or simply, we could just pass this .state. And so we're going to invoke this .props.onSubmit with this .state. And so now we have to define what are we actually doing on submit. So let's take a look at app.js. So here is a lot of stuff that we wrote last week, but we have not actually written the way to add a contact. And so let's go ahead and implement that here. So this should take an argument, so we need to know exactly what contact we want to add. So it takes a new contact, and what are we going to do? Well, we should take the previous contacts and append to that. And since we rely on the value in the previous state, we should define a function that takes the previous state and returns a new state where the new contacts are the old contacts and then the new contact. And so again, that ... notation with arrays means take all of those array values and stick them in this new array, and then last add new contact. And so now this function should take a new contact and set the state such that the contacts are equal to the old contacts with a new contact appended at the end. Lastly, we need to pass that handler down to the add contact form here. So we called it onSubmit. And what should do onSubmit? Well, it should invoke this .add contact, which will invoke that function that we defined up there. So let's go ahead and test that. So now we can go ahead, actually let's first just have only one to begin with so it's easy to see. Let's go ahead and add a contact. Let's call him my name. And let's put some random phone number in. So what happened? I clicked submit, but nothing actually happened. Does anybody see what the bug is here? So first, how are we determining whether or not we should display that add contact form? Well, here it says, if the state is telling me to show the form, then I should show the form. Where do we change that? Well, we have a function that says show the form, but there's nowhere in any logic do we say, oh, now it's time to hide the form. So where might we want to do that? Anyone? Yeah, in the add contact function. So when we add a new contact, we no longer really need to show that form, right? And so we could say update the contacts to the new contact and also say we don't need to show the form anymore. And so now, when we add a contact, the form hides, and that contact gets added to our application. Cool. Any questions about that? We can ignore that error for now. Cool. So is that a real phone number, 1234? It's not. So we should add some way to check whether the input is valid or not. And so next we'll talk about validating input. So one way to go ahead and validate input is to conditionally set the state based on input value. And so one bug that we actually have here is even though for the phone number only numbers are showing up, one, I can type dots. That's probably not ideal. And then things break if I don't define a name. So that is not ideal. And furthermore, if somebody plugs in a physical keyboard, they can also type things that are not numbers. And that is also probably not ideal. And so let's figure out some sort of way to say, hey, if this phone number is not a real phone number, we should not accept it. And so one way to do that is to conditionally set the state based on the input value. So let's go back into that form and do that. And so where might we want to check the value of that phone number before we update the state? So in line 33 here, we define the handle phone change, which is the function that gets invoked every single time that input changes. And what we're doing is we're immediately taking that string and setting the state, the phone in the state, to be whatever arbitrary string is passed to us. But we don't have to do that. We can actually add some logic here that says, hey, we should only allow people to set phone numbers to something that resembles a phone number. And so let's go ahead and do that. So we can say if phone, and then maybe do something there, then set the state. Otherwise, just don't do anything. And so what might we want to check on the phone? We should check if it's a number. And so how do we check if a string is a number? There are actually many different ways, and I'll show you one possible way. So this plus notation, if you do plus some string, it will try to cast that to a number. And so I can show you real quick. So say we have a string that's 123. If I just do plus str, we get 123 as a number. But what if I do plus 123a? Not a number. Plus empty string is the case where it'll return 0. But anything else that's not a number will return not a number. And so we can use this new operator to check if our phone number is indeed a number. So let's go ahead and say if the phone number is indeed a number, so is greater than or equal to 0, then we can go ahead and set the state. And so now here, if we start to type, I'm pressing letters and nothing's happening. That's because any single time that I type a letter, it's going to invoke this function. It's going to do if plus some letter or not a number is greater than or equal to 0. Not a number is never going to be greater than or equal to 0, and so that's never actually going to invoke down here. There's still a bug where if I do 1, ooh, actually, there's no bug. Right. So I was thinking that if we typed empty string here, this would be 0, but that still evaluates to true. And so even though phone is an empty string, empty plus empty string equals 0 is indeed equal to 0, and so it will indeed set the phone number to empty string. So that's one way to validate the phone number. And so now we are ensuring that the phone is some sort of number. We can go a little bit further because there's nothing stopping me from inputting a lot of numbers as my phone number. And so let's just assume that all phone numbers should be 10 digits long. And so we can stop the user from inputting a number that's greater than 10 digits long. How might we do that? Well, we can just do if phone dot length, and since it's a string, we can just check the length of it. As long as it's less than or equal to 10, we can go ahead and update it. And so now if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I try to press additional numbers, it doesn't update. Why? Because when I try to set phone to a string of length larger than 10, this does not evaluate to true, and so the state does not get updated. So there's still a problem here. What happens if I just click submit? Well, it errors because there's no name. And so we should probably also check that the name exists. And so we should also go ahead and validate the entire form before submitting. And so what else should we do here? Well, when we submit, we should make sure that both fields exist. And so we could say if the phone number is valid, and so let's just copy and paste this. So now phone.length should be equal to 10, and it should be a number. Additionally, we want that name to exist. And so let's just arbitrarily call this dot state.name should have a length greater than or equal to 3. And so now we're saying if this dot state.phone is greater than 0 when you cast a tune number, if the length is exactly equal to 10, and you have a name of length at least 10, then go ahead and submit the form. Otherwise, don't do anything. And so now when you try to add a contact with invalid fields, nothing happens. But that's not great UI, right? I should be able to know that I shouldn't be able to submit this form. And so let's go a step further, and actually every single time we change the name or the phone number here, we can change this button to appear like it should be clickable or not clickable. And so there's an additional thing that you can do with button, an additional prop that you can pass. We can pass a prop called disabled. And if we pass disabled true, then the button just looks unclickable, and it is unclickable. And so how might we use this to make the user experience of our form better? Well, we can actually continuously check, hey, if the form's valid, show the clickable button. And if the form is invalid, then say, hey, you can't click this button. And so where might we want to do that logic? Well, we can actually validate the form after we change any input's value. There's a couple places we can do that. One in this .setState. And so we've been using this .setState, and we've been passing it one of two things. We pass it an object if we want to just merge that object to the current state, or we've passed it some sort of updater function, which is a function that takes the previous state and modifies or returns an object modifying that previous state. Well, it turns out you can actually also pass a second argument to this .setState. And that second argument gets invoked as a callback. So after the state is done updating, it then invokes this callback. And so let's go ahead and use that to validate our form. So one, rather than just hard coding disabled true here, what might we want to do? Well, we can store in our state whether or not this form is valid. And so let's just call this isValidForm, or isForm valid. And we know that when the form is first created, that it's not. And so we can just initialize this value to be false. And so down here in the button, we can say whether or not it's disabled depends on the value of this .state .isForm valid. And so this will always start as an invalid form. And so we can see, disabled. It should be disabled when the form is not valid. And so we can see that when the form is first created, since isFormValid is false, we can't submit the form. That button is disabled. And now we can add some logic to say, hey, every single time we check the input, the form may now be valid. And so how might we want to do that? We're currently checking whether or not the form is valid right before we submit the form. But there's nothing stopping us from just abstracting that out to a new function. So let's call this validate form. And it doesn't need any arguments just because we're going to call it and it'll check the current state. And so here we can say, well, if these things are true, then maybe return true. Else, return false, because it's not a valid form. And so, although this isn't perfect, we can still have dots in our phone number. It's close enough. And so now, when we invoke validate form, it's going to check, hey, is the phone as a number greater than 0? And is it of length 10? So we'll just call that a phone number, even though it's not 100% rigid. And then, did they put something as their name? It has to be at least 3 characters. And if that's true, then we'll say, hey, it's a valid form. Otherwise, no, it's not a valid form. And so where should we invoke this function? Well, after a value changes. And so right now, the only 2 places that the values are updated are in this handle name change function and this handle phone change function. And so we can pass now as a second argument to this .setState, this .validate form. And as a second argument to handle phone change, the set state here, we can also pass this .validate form. And now this validate form function is going to get called after either of those functions are fired. As we've currently written it, validate form does not actually do anything. It just returns true or false. And so what should we do instead? Well, this should tell us whether the form is valid. And so if the form is valid, let's actually set state here too. And so now in validate form, rather than just returning true or false, it will actually update the state such that the isFormValid field gets updated to true or false. And so now let's see how our application functions. So when we first start this form, the submit button does not work. And let's add a name of 2 letters and a phone number of 10. And the validation still works. If we try to type more here, it doesn't let us. And now let's type a 3rd letter, and all of a sudden that submit button works. Why? Well, because when we pass another argument to setState here, that gets invoked after the state is set. And so after it updates the name value, now the name value in state is whatever it was when we typed in the input. And then it fires off this function. And this function says, hey, if the phone number is valid and the name is at least 3 characters, go ahead and say the form is valid. And what is listening to that is form valid part of the state? Well, it's the button down here. And so when that is updated, the button then flips from disabled to not disabled. And when we delete this and when it becomes invalid again, that submit button reflects the invalidness of the form. Any questions so far? So how are other ways that we can do this? Well, we learned a few weeks ago about the component lifecycle and how there are certain functions that are called every single time a React component does something. And in this case, we can actually use that, the hook that's invoked every single time the form or the component updates to go ahead and fire this as well. And so if we wanted to, rather than invoking this .validate form in handle phone change and handle name change, we could also do that in the component did update. And component did update takes a couple different arguments. One is prev props, and one is prev state. And what can we do here? Well, we can just call this .validate form. And so something interesting is going to happen here. We got a big error screen. Maximum update depth exceeded. This can happen when a component repeatedly calls setState inside one of these component lifecycle hooks. And so React is saying, hey, rather than just infinitely looping, we just threw an error. And so what is happening here? Let's take a look. So when we go ahead and type into an input here, a text input, something happens. One of these two functions is going to be invoked. What happens when it's invoked? Well, the whole component updates. And when the component updates, it calls this .validate form. What does this .validate form do? Well, it checks some things and then calls setState. And then when setState happens, the component updates. And what happens when the component updates? Well, it validates the form. And then what happens in validate form? Well, the component updates. And so we enter this cycle where it just infinite loops. And so how can we fix that? Well, component did update knows about the previous props and the previous states. It also knows about the current props and the current state. And so we can go ahead and check those values. We can say if this.state.name is different than what the previous state.name was, or this.state.phone is different than it used to be, then validate the form. Otherwise, don't do anything. And so now when we do stuff like this, it works. And when we type a 10-digit phone number, then the form becomes valid. What happens when it's invalid? Well, it works as expected. And then when it becomes valid again, then all of a sudden, that submit button appears again. And then everything else works as expected. And so the other place that we can validate a form is just in that component did update lifecycle hook. And so what's the difference? Well, not much. One difference is that when we add new functions, we also need to remember that in the set state, we need to pass that validate form field. But on the flip side, every time we add a new input, we also need to make sure that we're listening at the correct times in component did update. And so the performance of the two is equal. And so whether you choose one or the other is more personal preference. The way I would write it is I would prefer to put it in the component did update, but it's really up to you. This is almost complete personal preference. Any questions this far? Yeah.
So when you put the isFormValid function directly in the disabled attribute, does it not know to update that?
So the question was, when you put the isFormValid value here, does it know to update that? And so yes, so this is not the isFormValid function. It's just the state key called isFormValid. And the isFormValid key is updated when the validate form is called. And so React knows every single time the state is updated that the render might change. So what is outputted by render might change. And so every single time we call this .setState, the component is then re-rendered, and the correct value of isFormValid will be placed as this disabled prop to the button.
Do you always have to use the state to determine whether like disabled is true or not? Can you use a function instead?
So the question was, do we always have to use the state field to determine whether or not this function is, or this form is disabled or not? Could we just use an inline function instead? So the answer is no. So we could definitely, we can use a function here instead. And so say we actually validate form, say we implemented it how we did at first. So let's call this validate form 2, where rather than setting state to update that isFormValid field, we just returned true or return false. And then we can, yeah, and so now down here we can just invoke that function. This should work. So now if we, oops. This isFormValid 2. Oh, validate form 2. So if we call this validate form 2, so this should, in theory, work. I forgot to flip the Boolean, but you see that the Boolean does change. And so what is the difference between these two? The difference here is that this function is actually being computed as the render is happening. And so say it took a lot of work in order to validate this form. Say it took a whole second. What's happening to the user in that second? Well, nothing's showing up because React doesn't yet know what to render. And so the render here will take a full second. And so everything, the user won't see anything until a second later. And so that's considered bad user experience. Whereas when we do the validate form in the update cycle, it's already rendered this. So the user's already seeing this. And then when the component's updating, that's when it does the computing. And so the user sees what the user needs to see. And then the expensive computation is done after the user has already seen the form. And so there's, on the user side, he gets to see the form rendered before this is calculated. And so if you do it inline here, it's actually going to slow down the render. Whereas if you do it in like component did update, it actually happens after the render. And so the user gets to see the form before this computation happening. And so it would be better to just store that value in state. That way you can recompute it at a convenient time rather than having to do a potentially expensive computation during the render. Does that make sense? Cool. So let's revert this to this .state is valid form, and we're back to where we were. Great, so this works really well for short forms. But what happens if, say we wanted to center the form so now, in my opinion, the form looks slightly better. But when we're bringing up the keyboard, it's starting to get dangerously close to the input here. And so what happens if this form were slightly longer? Say now we had six things to fill out. Now when we click phone, we have something that's considered probably some bad user experience. That is, the input's getting covered up by the keyboard itself. And so you may start to run into problems like these when you're working on your projects. And so how might we go about in fixing that? So it turns out there's this thing called a keyboard avoiding view, which is a native component to handle avoiding that virtual keyboard. It's good for simple or short forms, but it doesn't really work well for very complex things. And what happens here, and the reason that's not good, is because the view moves independent of any of its child text inputs. And so let's take a look at usage of this component. So right now we have a view that surrounds these inputs. And let's actually import this thing called a keyboard avoiding view instead. So now rather than just using a view, we can use that keyboard avoiding view. And same up here. So now I have a keyboard avoiding view that actually doesn't look like it's doing much. That's because we need to tell it what to do when the keyboard arrives. And so we can pass it this prop called behavior, which is saying, hey, what should I adjust when that keyboard appears? It can be one of three things. It can be padding, which means when the keyboard appears, go ahead and add some padding to the bottom of the view so that all of the content moves up. It can be height, so that rather than being a full height view, it'll actually change the height of that view. Or third, it could be position, where it actually repositions the view. Which one is best depends a lot on your use case, and so the docs say, hey, just try whichever one's best, and you'll see. And so here, let's go ahead and use padding. And so now we've specified some behavior for that keyboard avoiding view. And so when we click, it goes ahead and moves that view out of the way of the keyboard. And when we're done, it goes ahead and moves it back. And how does this happen? Well, this view just gets some added padding. So this is a relatively new component, and it is still getting better. And so hopefully, this will be able to handle larger forms in the future. But for now, it works perfectly well for small forms that will fit in the space outside the view. So any questions on user input at all? Cool, let's go ahead and take a short break, and then after the break, we'll go ahead and look at some debugging techniques. Welcome back. So before the break, we were talking about a few different forms and how we handle user input in the forms. And there was a question in Slack asking a great question. And so in this form right here, we have two different inputs. We have the name and the phone, and we also have two different handlers. We have the handle name change and the handle phone change. This doesn't scale super well. Imagine you have a form with 100 different inputs. It would not really be a great component if it were filled with 100 different handlers for all of those inputs. And so let's go ahead and take a look at a pattern for how we can go ahead and update all of those handlers, but not have to write separate handlers for each of the separate fields. So if you notice, both of these fields look, both of these handlers look very similar. We have some string that gets passed in, and then we set the state such that the key is equal to that string. And the phone does some validation before, but it basically does the same thing. It takes a string and sets a particular key equal to that string. And so we can go ahead and abstract that out into a more generic updating function. And so let's just call it handle update. And that's going to take a couple different arguments. Let's actually have it take a key and return a function. It's going to return a function that says, take some sort of value, and then call this .setState. And in the object here, we're going to do something with the key and something with the value. And so we're going to take that original key and call it here, and update the state to be that value. And so for those of you who haven't seen this notation before, this basically means evaluate this expression, and whatever it evaluates to, cast it to a string, and that's going to be the key of that object. And so in this handle update function, we pass it a key first. And so imagine we want to do the handle name change. Rather than doing this, we can actually do handle name change is equal to this handle update. And we're passing it a key called name. Well, what does that return? We can go ahead and evaluate in our head. So handle update is going to be invoked with name. And so you're basically passing in name here as the key and replacing it down here. And so this will actually return a function that's value. And what does that value do? Well, it calls this .setState. What does key evaluate to? Well, it's just name, and it sets it equal to that val. And as you notice, this is logically the same as this. And so here, all we're doing is having a generic updating function that takes some sort of key, and when we invoke it, it returns a handler that takes a value and sets the key, whatever we pass it, to be that value. And just certainly here, we could start to do now handle phone change is this handle update. Let's actually name handle update to get handler. So it's slightly more informative. We're getting some sort of handler. Phone. And so this is slightly better, but again, for 100 different inputs, we're still going to have 100 different handlers here. And so why do we have to do it here? We don't really. We can actually down here, we can say for this text input called name, rather than doing this handle name change, we can actually just do this get handler down here and pass it the key that we want to update. And that's going to return a handler that takes a value and updates this key to be that value. And so for phone here, we can also do get handler and just pass it a phone. And that will go ahead and create a handler for the phone. And so rather than having a bunch of different methods or properties that handle each of the different keys for the values or for the inputs, we can actually just define one generic one up here and then go ahead and do it. Actually, there's a small bug, actually, where this should be returning that function. But rather than doing that, we can just use the shorthand notation like this. So rather than having a single line return, we can just use the shorthand, because arrow notation, if we're not, it just implicitly returns whatever's after the arrow. So this is saying this takes a key and it returns a function that takes a value and calls this .setState. And so if you ever see something that looks very weird, like a bunch of arrows pointing, it just means this, when invoked, returns a function, which may in turn return a function, and however many arrows are just the functions that are returned. But here, this is just saying, hey, to get a handler, pass me a key, and I'll return you a handler, a function that takes a value and invokes this .setState. So hopefully that answers the question in Slack. And so what's the difference? Which is better? Well, it depends. In this example with the getHandler, when we render down here, it's actually going to have to invoke that getHandler function n times for n inputs. And so that means if we have 1,000 inputs, it's going to have to evaluate that function 1,000 times in order to get the handlers. And so if we instead define those as class properties, rather than invoking getHandler 1,000 times for every render, it does it once when it creates the function, and at every render, it already has those as class properties. It can just pass those straight through. And so even though using this getHandler generic function is syntactically nicer, it's not necessarily more efficient. In fact, it's less efficient than defining all of those handlers as class properties. And so whether you use a bunch of different class properties or use getHandler here depends on what you care more about. Do you care more about efficiency for reading and how nice it looks to read, or do you care more about straight up efficiency and performance? Of course, there are ways to do both. And if you're curious, go ahead and post your question in Slack, and I will answer it after the lecture. But let's go ahead and move on to the next topic for now. So debugging. So there are a few different ways to debug React and React Native. Those are the React errors and warnings, Chrome developer tools, or you may see some online documents referring to those as the dev tools, this thing called a React Native inspector, and this library called React DevTools. And so I'm curious to know how you guys have been debugging thus far. Go ahead and post in Slack your various workflows for debugging. I personally like to leave a bunch of console.logs all over my files and then go ahead and just look, oh, that's what the value of the variable was at that time. But that's probably not the best way for debugging. There are actually a bunch of tools that can do that and more. And one is React errors and warnings. And so you have this thing called console.log, but it turns out that console object has other functions too. And so if you call this thing called console.error, what happens is you get that full page alert. And so you've seen this a few times in lecture. If we have an error or if we trigger something in React, that causes it to error out. And so you saw it earlier when we had the infinite loop and component did update. And so we can go ahead and just trigger that manually by doing something like, in render, we can just say console.error. This is a full page alert. And so now when we go ahead and render that page, we see a whole red alert with our error at top. And it also nicely gives us that a dump of the whole stack. So what were the functions that were called in order to get to that console.alert function? So another way to trigger this is also to just have an error, to throw an error. And so we can just do throw new error, And when we throw that error, it's actually going to get caught by React and shown as this function, as this big red alert box. And again, you see the stack trace where it was called in the add contact form. So this is probably a very, very aggressive way to debug, and probably not the best way if you're playing with your application, just be greeted by a big red alert. So there are also less aggressive ways by using these warnings. So a lot of libraries actually use either these full page alerts or these warnings to warn you or to alert you of something that's gone wrong. And so where have we before seen the yellow banners pop up? Well, it happens in prop types. So if we define some prop types for our function, and if we don't get the prop that we're expecting, that prop types library written by Facebook will give us a little warning. It says, hey, by the way, we were expecting a different type for the props, and we got this. And so that shouldn't really be a big error, but they're just warning you, hey, by the way, this is happening. And how do they do that? Well, they call this console.warn function. And so say we want to just do console.warn. This is a less aggressive warning. And so when that gets called, we just get a small yellow box at the bottom that's letting us know that a warning appeared. Again, maybe not things that you would use in your application, but if you're writing a library to be used by somebody else, you might want to warn them if they're using your library wrong, or throw an error if an error does occur. The caveat with these warnings is that they don't appear in production mode. And so if you have warnings and you go ahead and deploy your app to the App Store running in production mode, those warnings will not appear. So this is not necessarily super useful. So what's a better way to debug rather than leaving console.logs or leaving console.errors or console.warns? Well, maybe we should use the Chrome DevTools. And so for those of you who have ever written web applications before, you might be familiar with these tools. So Google Chrome has amazing developer tools, namely the debugger. And we'll take a look at that in a second. But if we're running a React Native application, how the heck do we get Chrome DevTools to work? Isn't Chrome a web browser, and aren't we trying to write mobile apps? Well, if you remember back to earlier on, we know that we can just run JavaScript in any Chrome tab. We know that we can also run JavaScript maybe in our terminal using Node.js. But how do we run React Native JavaScript in Chrome? Well, if you remember back, there are actually two separate threads, one for native and one for JavaScript. And how do they talk to each other? Well, they just communicate asynchronously through a bridge. It's just sending messages back and forth, like, hey, I need a button. And then the native will give you that button, and when it's clicked, it'll say, hey, JavaScript, my button was clicked. But does that mean they need to be running on the same device? Not necessarily. Since the way that they're communicating is just through this asynchronous message sending, that means we can run the native thread on that native device. And we can run the JavaScript anywhere. We can run it on the device. We can run it in a Chrome tab. We can even run it on somebody else's computer. And so we can actually go ahead and do that built into the React Native application here. So I can go ahead and say, shake my device. So I can go to hardware shake gesture, which is Control-Command-Z. And it goes ahead and brings up this menu. And I can say, hey, I want to debug my JavaScript remotely. So if I click that, I get a new Chrome tab open. And then we just move this to a separate window. So I now have a separate window. And if you look at the title here, it's saying React Native Debugger. And so the React Native JavaScript code is running as a web worker inside this tab. Or in other words, the JavaScript is executing inside this Chrome tab. And I can go ahead and open the developer tools. Oops, and I can see this. So if I go into debugger worker, localhost 1901, which is where this is running, I can go ahead and see all of this code. And if you look at something like add contact form, you see exactly what we have been working on recently. And so you see that get handler. Let me make the text bigger. You see things that we've written very recently, like that get handler function that takes a key and returns a handler, a value in that set state. And so we can go ahead and use the power of Chrome's debugging tools to go ahead and debug our app. And so let's go ahead and throw a bug in our app and try to find it. So let's go ahead and rather than using this .state.name.length to check name, let's try to enforce that the user have both a first name and a last name. And so let's use that in order to decide whether the form is valid or not. And so how might we do that? How do we check to see if the user has given us both a first name and a last name? We can just count how many words are there, right? So let's go ahead and do something like const names are this .state.name .split, and then split at every space. And so for those of you who've never seen this split, it basically says with a string, given a string, every time you see whatever argument I pass in, go ahead and return to me an array that's tokenized by that character or string. And so in other words, every single time I see a string, give me the tokens around those strings. So in hello space world, give me an array containing hello and world. And so here, let's just assume that the user gives us a first name space last name. And now names will be an array of two names, the first name and the last name. And so now let's check if names.length is greater than or equal to 2. Then let's call that a valid name. Now down here, let's get rid of all of those extraneous text inputs. So delete here. And now we're back to just those two things. And now we're using that getHandler method. So let's go ahead and try to add our name. And make sure that the validation is running. So disabled gets this .state.isValid form, the opposite of that. So now hopefully we're in the state that we were before, where the form starts invalid, and if I give it a valid phone number and a valid name, is it getting called? It must not be. Component did update this .validate form. So let's see if it's actually getting called. And how might we do that? So time to debug. So for those of you who've never used a debugger, what it allows us to do is set breakpoints. And what are breakpoints? Well, it's a point where if this code path gets hit, meaning if this code is about to get evaluated, stop and give me a chance to look at some things. And so we can go ahead and in that DevTools window, we can say, hey, right before this gets called, let me stop and inspect some things. Let me take a look around. And so by clicking on these numbers around here, some things get called. You see these blue highlights appear. And that is me adding a breakpoint. And so now, right before this line gets executed, it's actually going to pause and let me look at some things. So now let's make sure that gets triggered. Okay, so as soon as I changed my name here, it triggered this. And it says pause on breakpoint. And so now I can see the call stack, meaning what are all of the functions called in order to get me to where I am now. And so you see a lot of this is React internals, but you see something that looks like this .validate form, which is from that add contact form that we were writing. And so it makes sense that those were the most recent functions called. And we also see scope. We see all of the variables within our scope. And so if you remember back to earlier lectures, we talked about scope, and scope being all of the variables that I have access to at any given time. And we see that names is currently undefined, which makes sense. We haven't evaluated this line yet. And we see some closures, which, as you remember back a few lectures ago, are functions that still have access to all of its parent, the variables in scope of its parent. And so we see this add contact form, which is this form that we're inside of. And so we see all of the global variables as well, which there are a ton. But let's look at what we really care about. We really care about names right now, which is undefined. And so we can say, hey, rather than, we can click this button to resume the execution, so it'll just keep going. Or we can just step over this next function call. Or in other lines, go to the next, in other words, go to the next line. We could also choose to go into the function if we want to, if we think, oh, it's not my code that's breaking, it's actually this .split code that's breaking. I can choose to see how .split is implemented. But I think it's a safe assumption that the bug here is mine and not the JavaScript's. And so I can say, OK, let's go to the next line. And so now we see what's highlighted. We know that line 57 has just gotten executed, and we're about to execute line 58. And so now what is in scope? Well, names got updated. Now names is Jordan space Hayash, which is what we were writing in the input. And so now we can go ahead and step through our code line by line to see where the bug is. And so now we can go ahead and say, OK, we're checking phone, we're checking phone's length, and we're checking names.length. And so this worked. And so now we're on line 59. And so it's about to say, is form valid true? Cool. Click next. And then what is happening now? So now it updated everything, and now we're in the next cycle. So it's validating the form again. And so we can just keep clicking through. And now the component did update is done. So this .validate form is finished, and now it's going to finish updating. We can just hit play. It looks like we're stuck in a loop. What's happening over here? OK. So we saw that the problem was not in this validate form. Names was getting set to be what we thought it was being set to. And we saw that this .setState is form valid is getting updated to be true. And so the bug lies somewhere else. So is form valid is getting updated as expected. And so down here, we see why isn't disabled getting updated? Well, this .state is valid form does not exist. What are we calling it? Well, we're calling it this .state is form valid. So we see up in the state, we're declaring as form valid. We're updating it here. And that is what we should be looking at rather than is valid form. Cool. So we caught the bug. And now we can ensure that it works. Great. Now it worked. But let's say, oh, I made a typo. Let me go back. Hey, wait a second. Is there a first name and a last name? No, but it's saying that the form is still valid. And so now we have another bug. And so let's now go use Chrome DevTools again to figure out what the bug is here. So let's again set a breakpoint here and go ahead and find that case. Ugh. And now when we hit a space, now we're back to where we were on the case that has been tripping us up. And so now we're about to execute line 57. We see names is undefined. And so let's go ahead and execute that line. And now we see names is of length 2. And what is that array? Well, the first name is Jordan, and that second string does not exist. And so names.split is doing what we're telling it to. We're saying split it at every space. And right now, this .state.name, we could dig for it in here. So this .state.name is Jordan space, which isn't a first and last name pair. But the way that we're defining whether or not a name is of length 2 is getting fired. So again, this .state.name is Jordan space. And we see that names.name.split at space is giving us 2 entries, Jordan and empty string. Because it is splitting at the space, and what's after the space? Well, an empty string. And so we see that here, this is returning true when it should not be. And so now we can go ahead and fix that bug. So rather than saying names.length is greater than or equal to 2, what do we have to do instead? Well, we should also check that names, the last name exists. And so we can just do, hey, remember back to what are all the falsy values? Well, empty string is a falsy value. And so if names bracket 1, meaning the last name, if that's an empty string, that shouldn't be an accepted value. And so now let's go ahead and remove that breakpoint. So we are in the file called add contact form. Let's go ahead and remove that breakpoint. And now we see that if I do Jordan space, whoop, let's give it a valid phone number, Jordan space, oop, it's still erroring. Did we remember to save? We did not. So again, phone number, Jordan space, and it is not a valid form. And so we can use Chrome's debugger tools to go ahead and step through our code line by line and see all of the variables that are in scope. And so we can catch bugs like this, where what we think is the case that we're looking for might not be. And actually, it's still slightly buggy. Can anybody see the bug? So if we have a leading space, we're only checking the last name. We're not making sure the first name is existing. And so if we can fix that real quick, we can say, oh, names 0 also needs to exist. And we'll call that good enough. So now with a valid phone number, space, Hayashi doesn't work, space space doesn't work, and it only works as soon as we start to add that second value. Great. And so another great thing about Chrome developer tools is the console. And so I said earlier how I love console.log. And let's actually look at a case where console.log works in the browser, but it might not work in other environments. So let's go ahead and stop remote debugging. And so now we're running the JavaScript not in the browser. And so let's go ahead, and every time we want to validate the form, let's just console.log the form, or this.state. So now when we're changing the state, we see things are updating over here. And so the logging of the JavaScript is getting piped over to the Expo XDE. And we see down here, when we console log this.state, we see an object that has all the keys and values of state, where is form valid is false, name is J, and phone is empty string. But what happens if that object is pretty complicated? What happens if that object has a cycle? So now we're sticking inside of state. This is equal to this. And so this here is going to have this dot state in it. And so this dot state dot this is going to be this. Do you see how this is going to start becoming circular? And so this is called circular JSON, or a JavaScript object that self-references itself. And so now, if we start to type anything here, things just aren't going to work. So this is now a valid form, but it's not showing as a valid form. Why? Because this initial console.log is still trying to happen. And so you notice that nothing here is getting logged. It's because it's still trying to figure out what to log. It's going through that infinite cycle. But turns out if we try to actually do this in the browser instead, so now we're back here. Say we type something over here. It works. And so you see, so Chrome's logging abilities are actually phenomenal. And you can see that it gets printed 4 times because we changed the value 4 times. And what do we see here? We see is form valid false, name test, phone, empty string as expected, and then we see this, which has in it this dot state, which has in it this, which has in it this dot state, which has in it this, and this can go on forever. And so the logging abilities of Chrome are actually pretty incredible, as are the debugger. And so this is a great way to go ahead and debug. You can step through your code line by line. You can have these pretty complex console.logs, and it all works. So what happens if the bug is not logical? What happens if the bug is rather in the layout? So let me introduce a small bug. Let's actually go ahead and stop running this remotely. So now we have our form. It's at the top like it was at the beginning. And say now we want to try to get it to the center. Let's try to center this form vertically. The way you would do that would be justify content into the center. And that, in theory, is going to take all of the content of the container, which is what we're calling the wrapper, and move all of its content to the center of its height. But as we see, it's not moving down to the center. And those of you, some people may see instantly, oh, exactly what's wrong. But it's pretty not obvious. We have it supposedly centering, but it's not moving to the center of the screen like we're expecting. And so this is not really something you can debug using the dev tools or console.log, because it's not a logical bug. This one has to do with layout. And so it would be really great if we could just inspect all of the layouts. Fortunately, we have something called the React Native Inspector. And this is analogous to that Chrome element inspector. So those of you with a web background probably use that element inspector where you can see all of the DOM elements and see exactly where they are on the page. It also allows you to see data associated with those elements, like margin, padding, size, etc. And so we can actually go ahead and use that tool. We can go ahead and close this. We can use that tool to figure out what's going wrong here. And so again, if we shake our device, we can see this toggle element inspector button. And if you click on it, we see this UI pop up. It says tap something to inspect it. And so if we go and click this inspect button down here, that'll toggle on. And so now we can click anywhere, and we can start to see all of the styles associated with something. So say we click on this input, we see down here, this text input is in addContactForm.js, which is exactly where we defined it. We see all of its style attributes. It has a border width of 1. It has border color black, min width 100, margin top 20, etc. And we see exactly how it's laid out. And so imagine that this was a box. We see its margins. So it has a margin top of 20, bottom, there's no margin. And on either side, it's 20. We see some padding. And we see the dimensions of the element itself. And so that's helpful information as we're trying to determine how are we trying to lay out our UI elements. And so what's the buggy part? The buggy part is that form that we say, oh, it should be centering its content, but it's not. And so let's go ahead and find that form. There's a submit button. Oh, there's that form. This is the keyboard avoiding view in the add contact form. So it has a background color of white, has a padding top of 20, justify content center, padding bottom 0, all these things that we define in the style. But the height isn't what we're expecting. We're expecting it to be full height, but what's being highlighted is only this here. And so blue refers to the height of the element itself. Green refers to its padding. And so it is centering its content. If you imagine the height is here, everything's perfectly centered. It's just the height is not what we were expecting it to be. We thought the height was going to be the full, and so center should be here. And so we found our bug. The bug is that we just need to make the height full height so that when it's centering its content, the content is in the center of the device, not the center of this view, which is not as tall as we thought. And so if you remember back to section when you guys talked about Flexbox, we can see the bug. So the container should be filling all of its available space. We should say flex 1, so grow as much as you can. And now it's centered again. And how can we confirm that? Well, we can click on that add contact form, and now we see it's blue all the way down. And we see the height is now what we expected. And so for testing UI elements and seeing exactly how they're laid out, their size, their padding, their margin, the inspector is a great tool to be able to do that. The caveat with this inspector is that it doesn't allow you to live edit these elements. So when I wanted to change the flex to be 1, I actually had to go do that in the source code. I had to rebundle the JavaScript, have the bundle get sent to the app, and have the app reload. And it doesn't allow me to just hop in there and change things at will. Since I'm talking about that, you can probably guess there is a tool to do that, and that tool is called React DevTools. This allows you to inspect the React component hierarchy, so you can see the entire React tree, including the components, the props, and its state, its style. And how do we run this? So first, you have to install it. So if you run this command, npm install -g, which stands for globally, install this library called React DevTools. And so we can go ahead and do npm install -g React DevTools. So I already have it installed, so it's going to happen fairly quickly. But for those of you at home who don't have it installed, you can go ahead and install it globally now. And this will allow us to go ahead and use this tool called React DevTools anywhere. And so when we want to run it, all we have to do is type React DevTools, and it will open up. It'll run the command and open it up. And what that does is it allows us to make live edits to style, live edits to props, etc. And if you want to read more about it, you can go to its GitHub page. It's also maintained by Facebook, and it's a brilliant tool. So let's go ahead and give it a shot. So notice we just run it as React DevTools. We don't have to tell it where our app is, and it will just go ahead and find our application. And so now we see this. We see app container, and if we start to unfold these things, things are going to start to become pretty recognizable. So we're starting to see things that we've named: add contact form, app, text input button, and as we hover over them, you can see them highlight over here. And how's that working? Well, it's actually working with the inspector to do that. And so now let's go ahead and reintroduce that bug. Let's go ahead and reintroduce that bug into add contact form. We can get rid of that flex. Let's get rid of justify content center as well. And so now we're back to where we started with that original bug, where we want to center this, and we're going to have to figure out how. And so let's do that in the React developer tools. And so you can see that this tree here matches up exactly with the tree that we've defined in our code. And this is actually the React element tree. And so we can find that keyboard avoiding view, and we can see the style here. We see background color is FFF, and padding top is 20. And that matches with exactly what we have here, where 20 is just getting the value of this variable. And so now we can actually add in line whatever we want. We can say, right now, if we highlight over this with the inspector on, we see that this keyboard avoiding view is only this tall. It's only as tall as its content. And so let's first get that to fill. And so we can go ahead and just say, oh, I wonder what's going wrong. Let me add flex 1. And so now, all of a sudden, keyboard avoiding view is filling all of the available space, which is exactly what we're telling it to do. We're saying flex grow until you fill all of the available space. And so now we can go ahead and center all of its content. You can say justify your content to the center. And you see it jumps immediately. And so this also allows us to inspect all of our component state, our props, anything that we care about. And so right now, inside our form, so say we can't find our form, say it's buried deep, we can just go ahead and search form, and we find our add contact form. And you can see its subtree here. Right now, its state is saying is form valid false, name, phone. And as we change things, you can see things live update over here. And so as the state of the app changes, you can see it update in the DevTools here. And so this is a great tool to make sure what you think is happening to the state is exactly what's happening to the state. And you can even override this. Let's say the phone should be this, and it will go ahead and set that state for you. And so this is all around great tool for inspecting state, setting state, making sure things happen when you set state. You can go ahead and inspect style, and go ahead and quickly prototype so that you don't have to type all of your style into your text editor. You can just see exactly how it's going to impact your application. And then if you like what you see, then you can go ahead and then commit that and save it in your text editor. You can also see what props are coming down. You can ensure that you're passing the props that you think are passing down. So this is just a great tool to be able to see exactly what React knows. So any questions on React DevTools, the inspector, or Chrome DevTools? So let's move on to our last topic. So external libraries. So how did we get React Dev Tools onto our computer? Well, we use this thing called npm. And React Dev Tools is actually just an external library, external code that we're bringing into our own project. So libraries are code written outside the context of your project that you can bring into your own project. And so these can be written by you, they can be written by other people, or they can be written by companies or anybody, really. And so stuff like React is a library. It's a library written by Facebook that we pull into the project that we're writing just because we want the ability to use all of the features of React without having to write the code ourselves. Imagine every time you want to write a React Native application, imagine you had to write all of React Native. That would not be fun. And in fact, it would not be fast at all, which is the big benefit of writing in React Native. And so what we can do is we can actually use other people's code and bring that into our own projects. And so since React Native is just doing JavaScript, it's writing JavaScript and evaluating JavaScript, you can add any JavaScript code to your project. And so any library written in pure JavaScript, you can just pull in and use that code in your project. And so there are plenty of great tools that give you a bunch of functions that you can use, so like Lodash, underscore, Ramda. These are all just tool belts that give you access to functions that you might use very often. And you can just go ahead and pull all of that JavaScript into your project and use it as you see fit. The way that you install these things is by using npm, or Node Package Manager. For those of you who are not familiar with package managers, is it allows you to just, it manages the packages for you. These packages synonymous with libraries. And so you can say, rather than me having to go and find where the source code of React is and download it and then upload it into my project and then go ahead and import it into my project, oh no, versions don't match. That's all taken care of for you by this thing called npm. And so if you say, hey, I want React, you can just say npm install React. It will find where React is located for you. It will download it for you. It will keep track of the correct version number for you. And then you can just go ahead and import that into your project. And how does it keep track for you? Well, that's what that package.json is. So every single project that we've seen before, there's this thing called package.json. And inside it, there are a few different key value pairs. And one important one is called dependencies. Dependencies, or another word, what other code do I need in order to make this application work? Obviously, I'm going to need React, because we're using every single file. The first line is what? Import React from React. Well, where is React? Well, it's right here. And so what this package.json does is it says, hey, this is the exact version of React that we need. npm, go find that for me, go download it for me, and keep track of where it is so that I can import it into my project. What else do we need to run? Well, we need Expo, and we need React Native. And if we need other libraries, we need to make sure that they're here so that when other people want to use our project, they have those when they want to install. And so many of you have probably used this command called npm install, and now you know exactly what it does. Is it reads through all of your dependencies and goes and finds them and downloads them for you. And so now, let's say in row, we want to define some prop types. So we've seen before this line, import prop types from prop types. And then we go ahead and use it. We can say row.proptypes is this object where we're expecting a name, which is a string, and we're expecting phone, which is also a string. So we've gone ahead and imported this thing called prop types from this library called prop types. But what is prop types? Well, this is actually going to work, believe it or not. And it's a little bit strange why it works. The reason that it works is because other libraries that we're importing also import prop types. And so it happens to be the case that prop types is already installed for us. But we're not guaranteed that it's already going to be installed for us. So what we should do is npm install prop types, which is saying, hey, in this project, we actually need this external library called prop types. npm go install it for me, and then make sure to note it. And so now if you see in our package.json file, prop types was automatically added for us. And so npm is this great software that just manages all of our packages for us. It finds what we need, it installs it, keeps track of the version numbers, and it makes sure that whoever is using my project, when they type npm install, they get the dependencies that they need to run my project. And so if you're using an npm version before npm 5, and so you can tell what npm version you're using by doing npm-version. I'm running 5.6. Since that is newer than npm 5, I don't need to use this --save flag. Before npm 5, if you just did npm install, it wouldn't add it to your package.json, and now that's the default. But if you are using an older version of npm, then you're going to have to use that --save flag. Or if you want to install a library globally, so like we did with React DevTools, you're going to have to use that -g flag. And what that does is it gives you access to that library everywhere on your computer. And so the reason that we could just type React DevTools at the command line is because that package is installed globally on our computer. The reason it wasn't working is because there's another one running on a separate window. And then lastly, all we need to do is just import it into our project. And so a line that we see all the time is import React from React. What that does is it says, hey, go get that package called React, import its export default, or its default export into our project, name it React, and now I'm free to go ahead and use that. And so if I want to use any other library, all I have to do is npm install that library, make sure that it's added to our package.json so other people who use our project can go ahead and install that for themselves, and that's done automatically by npm. And then we can go ahead and import that into our project and use it as we please. And so in future lectures, we'll see other JavaScript libraries that we'll be using. So React Navigation we'll see very soon, and we'll see other libraries like Redux. That's just us using other people's code to our benefit. We don't have to re-implement other people's projects. We don't have to reinvent the wheel. We can just go ahead and build upon what other people have written on our own app. And so a lot of non-replicated effort on our part. And so next week, we'll go ahead and dive into navigation. We'll see how, right now, we're using that, if the state says to show the form, go ahead and render a different page, otherwise render original page. Next week, we'll see exactly how we're going to do that scalably. Because right now, if we have 10 different pages, we don't really want, if this page is visible, render this page. If this page is visible, then render this. We're going to see a library that allows us to better navigate our application. And it'll give us the ability to have things pop on top of each other, go back and forth. And so we'll dive into that library. And so we actually have a guest lecturer, the people who wrote the library itself, join us next week. And so, or next lecture. Next week is spring break. And so we have that to look forward to in the coming lecture. So thanks, everyone.